sharing this. Today, we'll cover wireless LAN, WLAN, or Wi-Fi network. Okay. In the past, Wi-Fi was not available in CCNA course, but nowadays CCNA is very advanced, covering many areas. In fact, it covers almost all areas, at least to some extent. Okay. So we'll go through Wi-Fi concepts, but unfortunately, packet tracer doesn't support so many features of WLAN. But devices are available in packet tracer, but they are not fully functional, or they are not with full features of Wi-Fi devices. That is a problem. However, we will work with some lab also after going through some concepts. Okay. Wireless LAN or Wi-Fi is very common, I would say, pervasive everywhere, or wherever we go, whether you are at home, at coffee shop, or at your office, or at your university, everywhere you have Wi-Fi access. Some are free, some are personally arranged. So in enterprise environment, you have to manage Wi-Fi network as well as a network engineer, network professional, or network administrator. So, so let's go through some concepts that you may be familiar with, but I am repeating those. Okay, WLAN is IEEE 802.11 standard. Okay, and it uses shared medium, which is the radio frequency. Electromagnetic wave is the basic thing here. Okay, and wireless access point AP is responsible for radio transmission, which we call Wi-Fi router. Okay, sometimes we call Wi-Fi router at home because it has some routing capability. Okay, you have Wi-Fi at your home. It is true for almost all people, because nowadays we are connected. We are always on. We are connected to always on network. Few years ago, we used to connect internet using mobile data, but that was very costly. Still, that is very costly. So it is feasible to establish Wi-Fi network. Okay. So there will be two terms. You will be a Wi-Fi router, Wi-Fi access point. There are some differences of the terms. Wi-Fi routers means, for example, in appliance that we install at our home or office or in there, it has many functionalities in a small box. It has routing capability. It has small switching capability. Maybe 4 ports are available for.
And then click on map.
Okay. Are you saying anything? Okay. It has built-in DNS. It has DHCP server. It has Wi-Fi transmission and system. So there are several functionality in a small box. But in enterprise environment, you may call them access point or lightweight access point that has only radio transmission, Wi-Fi transmission system, and routing capability will be transferred to another device. Okay, we'll go through all this. Okay, two important terms. How Wi-Fi network is identified in a network by our handheld device, our laptop, our computer, or a tablet, or any other device. How they can identify using, we identify network using service set identifier, which is classes ID. Okay, it is a text string. Just you give a name to your network. Okay, but it is not unique. Anyone can give the same name. Okay, not problem. But it is disturbing. And how it is uniquely define the network? BSSID, sorry, BSSID. BSSID, basic service set identifier. It is based on MAC address of the access point. Okay. So MAC address is unique. So even though someone created a network with same SSID, MAC address will be different. How? That is why BSSID will be different. So network can be identified uniquely. However, are only malicious actors who try to hack your network may create the same MAC address. Okay. So in this figure, you can see that a Wi-Fi AP is at the center, and there are some devices are connecting via Wi-Fi signal. AP has two things. One is BSSID, one SSID. Look, BSSID is just a string, say my network, and BSSID is MAC address of the radio transmitter. Okay, it is just MAC address. But what if you have more than one SSID? In that case, in Cisco Wi-Fi system, MAC address is implemented by one for each SSID. Sometimes we create several SSID. Say, for example, one for students, one for teacher, one for administrative staff, say in your exam, university, or one SSID for guests, for example. Okay. So different Wi-Fi SSID are created at different organizations so that their passwords pre-shared key can be managed more conveniently. Okay. But they have different SSID also. Question may arise, if MAC address is one for each device, how this SSIDs are created. Okay, SSIDs will be created by implementing one with the MAC address. Okay, but it is based on MAC address. Okay, how it is connected to your wide network. Okay, up until now, we discussed about wide network, which are connected to by fiber or Ethernet cable, okay, which is copper cable. But now we are talking about wireless. But wireless network is connected to wide network. It is connected in this, there is a switch. Maybe it is ISP switch or maybe your organization switch. In case you are in a big organization, then of course it has its own campus network. Okay, this campus network will provide connectivity to Wi-Fi access point. Okay, you have some people roaming or they have some mobile devices. Okay, almost everybody one or more device, Wi-Fi device. Okay, that is why Wi-Fi network is very important. Okay, so Wi-Fi network cannot be avoided. So we just connect our Wi-Fi access point or Wi-Fi router to a switch port. Okay. In switch port, and which mode will connect? Can you say whether it is access mode or trunk mode? Can anyone discuss? What about Ubad Abbas? Can you hear?
Yes, sir.
Yeah, can you guess or know about the connectivity of AP or Wi-Fi router with your switch? Will it be access or trunk connectivity?
I'm not sure, sir.
Okay, okay, good. No problem. Okay, normally it can be access connection. Okay, if you are using 1 billion, okay. But if you want to multiple VLANs in AP or Wi-Fi access point, in that case, you will use trunk, because trunk connectivity is used to pass multiple VLANs. Okay, look at this picture. In the previous picture, we are just passing 1 VLAN. Say VLAN 10. VLAN 10 contains only Wi-Fi traffic with only SSID, only BSSID. But what if you are creating multiple SSID? Okay, maybe you have experience. I don't know how many of you manage your own Wi-Fi router at home. I don't know, but you should manage. Okay. In that case, you will see that you can create multiple SSID. Okay. In some organization, there are requirement of multiple SSID. Okay, In that case, you create say my network is SSID, your network is another SSID, for guest another SSID guest. Okay, there may be some traffic separation. Okay, it is pointless to create multiple SSID without any traffic policy for different SSID. Okay, normally we create different SSID to create different policy. Okay, say we created one network for internal employee, one network for guest. Okay, for guest, we will not allow some internal routers. Okay, sorry, internal servers. Maybe there are some internal servers which contain confidential information. So you are not allowing any guest to access. So what you will do, you will not allow those IP addresses to guest network. So it is a policy organization. Okay, you have network for administrative staffs SSID. Okay, you will not allow the management switch and router management connectivity. Okay, so it is another policy. So in this way, you will classify different traffic, allow or disallow different traffic in different SSID, applying access control list, ACL. Okay, ACL as well as some routing. Okay, maybe you will not allow routing with this subnets in the router. There may be different policies, but ACL access control lists are very much relevant to this scenario. So to protect your network from unauthorized use, you will segregate traffic here using different SSID and applying different policy as per your organizational requirement. Okay, that is why we use multiple SSID, and they have, of course, corresponding BSSID, which is based on MAC. For every BSSID, MAC is just incremented by 1. Okay. Okay, another concept is extended SSID. Extended SSID is imagine a large campus area. Okay, where one access point or Wi-Fi router will not be able to cover because electromagnetic signal of access point depends on transmitted power. So 802.11 standard has a specific definition or range of power. You cannot increase the power or you want. Okay, there is a range. So within range, you have transmit power. So it will cover a specific range, and beyond that range, the signal will be attenuated, and it will be very weak, and devices signal to noise ratio will be very low. So devices will not be able to connect to Wi-Fi network beyond the look at this some circular region. Okay, so normally we use omnidirectional antenna. In that case, it will transmit a Wi-Fi signal or 360-degree around the antenna. Okay, but there are other types of antenna like directional antenna. So you can focus your antenna to a specific direction, and so that you can cover a specific area. Okay. So in that case, you have to install multiple Wi-Fi AP. Imagine you are in a campus where it's a very large area. So you have several access points. Okay. For every access point, you have SSID and BSSID, and you have pre-shared key. So whenever you go there, you collect password or passkey or pre-shared key, and then configure in your computer or device. And whenever you move to other device, then you collect another set of information. However, it is not convenient. So roaming facility is required. So ESSID, so extended SSID is used when you need roaming facility. That means whenever you go, every access point has BSSID, same BSSID. Okay. However, they have different, same SSID, but they have different BSSID, because BSSID is different, depends on MAC address of the AP, okay, which is different for every AP. Okay, for large organization, we use ESSID, where we use AP at different places wherever people all move. And one important thing is that all the devices in the Wi-Fi network connect with each other or via AP. They cannot directly connect each other. Okay, because AP can control all the traffic. Otherwise, it is not possible. So all the devices in an AP, say you are at home, you have several devices connected to your Wi-Fi network, but from one device to another device, you are trying to transfer some data using Wi-Fi. So Wi-Fi, although Wi-Fi direct, different technology are there, but apart from that, if we are trying to use our home or office Wi-Fi, in that case, data must travel through AP. Okay, but independent base service set, basic service set is also possible for some cases. There are some devices like a printer, some sort of printer can directly connect with a computer, which is ad hoc, which is called ad hoc or point-to-point Wi-Fi connectivity. Okay, this is also possible. This type of devices are also there, but they are rare. Okay. But this is possible. And when all devices connect via AP, we call it infrastructure mode. Okay, AP has different modes. We will also discuss. Sorry, Wi-Fi router or AP has infrastructure mode, ad hoc mode, which host can connect point to point. Okay, and then we have repeater mode. Repeater mode means when as I just discussed, every Wi-Fi AP has a specific range. Beyond that range, the signal gets attenuated and weak. Okay, and device cannot connect because signal to noise ratio is very low. Okay. So in that case, one AP can be can say at the border of the. Do I have any? Okay, here is a picture. Okay, at the border here, one AP is connected to your wide network switch, and it has a serving area. Okay, it can serve, but at the border of this serving area, signal are weak. If there are devices that cannot connect to the network, in that case, you will install another access point which is in repeater mode. Repeater mode means it will receive the signal from the AP and retransmit with stronger amplitude. Okay, so the devices further or beyond the first AP's coverage area can receive the signal from repeater. Okay. So it is a repeater. Then we have.
So, sir, if you have wireless controller, can you still achieve the same?
Okay. Wireless controller, I'll discuss very soon. Okay. Then we have bridge mode. Okay. Bridge mode means sometimes we connect to remote LAN with Wi-Fi network for some reason. Say you have a building here, and beside the building there is a road. Okay, you are not allowed to cross a cable over the road. Maybe your municipality or your local government authority will not allow for some reason. Okay, what will it do? So another building is across the road. In that case, you can put one AP here and another AP on the other building, and configure them in bridge mode, and they can link bridge to LAN. Okay, it can be more. Okay, there are okay, LAN, wireless LAN has standards, different standards. Okay, we call basically it is 802.11. Okay, IEEE standard. Okay, there are different standards about time. Wi-Fi network has gone through evolution, and still it is evolving. In the beginning, the data rate was, for example, legacy 802.11, which has data rate of 2 Mbps. Okay, and over time, there are different standards like 11B, 11A, 11G, 11N, 11AC, wave 1, wave 2. Then finally, recently we developed Wi-Fi AX, Wi-Fi 6, which is known as Wi-Fi 6. Okay. And there are different frequency range, 2.4, 5, G. Okay, 2.4 and 5G are two frequency, and they have different bands. Okay, channels are available, fixed. There are fixed channels. Okay. So they use different modulation techniques, and legacy network use frequency hopping spectrum or direct spread DSSS. So these modulation are used, but newer or higher rate Wi-Fi standards use OFDM, okay, orthogonal frequency domain multiplexing. But most recent or higher rate, which carry GBPS range data rate. But earlier, you know that you can see here that 54 Mbps, 450 Mbps data rate, and over time it is improved. Wi-Fi 6, which is now available, most recent Wi-Fi devices, latest handset, mobile handset has Wi-Fi 6 capabilities, and all, of course, the latest laptops and Wi-Fi dongles. This capability it has huge capability. It can use multi-user MIMO, multiple input, multiple output. That means it can use multiple antenna. Okay, within a antenna system, there are multiple transmit and receive capability. Traditionally, we had just one transmit, one receive. Okay, single transmit, single receive. But it has improved over time. So data rate of those hardware have improved significantly. Okay, they use okay. This modulation may not be that important, but you can know that quadrature implicit modulation 64, 256, 10.024 means it can carry larger increasing bit rate. Okay, per symbol. Per symbol means if it sends a signal, it can carry different numbers of bits depending on modulation. Okay. So, for example, 1024 QAM modulation can carry huge bits compared to 64 QAM. Okay. But here you have to know that or recognize that there are different standards. When you are in a device, you will see that these standards are available. In most cases, we configure our Wi-Fi router as mixed standard. That means they can transmit several standards, or they can use. But there are some devices that can only support one or two standard. In that case, if your device is not configured accordingly, communication may fail. Communication will not be possible. Okay, so standards are important. Okay, and data rate. Okay, you know that just data rate, higher data rates are Wi-Fi 6, which is originally known as Wi-Fi AX, and AC also higher rate, but A, B, Z, N. Okay, these are available in our Wi-Fi routers and device and receiving device. Okay. You ask.
So, sir, how can we determine which standard does our devices support?
Okay, which device? Okay, almost all device, all standards are available in your device. If you go to your device settings, you will be able to see it. Okay, how you can see?
Wireless. That
let
is
me-
wireless.
Let me check in the Wi-Fi connection in the mobile and Wi-Fi. Let's check Wi-Fi. Go to Wi-Fi. Then Wi-Fi. You will have settings. Okay, advanced. Okay. 1 minute. Okay, I'm not seeing here. However, okay, there should be, but in case of, okay, I'm showing you one. Look, wireless. Okay, look at this. Here, your network is BZN. Okay.
Yes, sir.
BZN. Okay. Like this, it is a live Wi-Fi router, which I show. It's my home router. You can configure accordingly, but my device has no capability of AX-AC. Okay, AX-AC. When you purchase the device for your home or office, check which standards are available. Maybe some low-cost device may not have all the standards, but you buy latest product. You will have Wi-Fi 6. Wi-Fi 6 I will recommend, although it is not available old laptops or old mobile phones. Okay, but if you buy recently, definitely they are available. Okay.
So my question is, if you have router with Wi-Fi 6 standard, and then you have computer, let's say with 802.11g standard, can they communicate in that case?
No. It is not.
So the best way is to check your client computers before you buy a router.
Of course, you will understand the latest device, or when you. Okay, I will talk at the end of this these slides. You will see how we plan a Wi-Fi network. Okay. Okay, let's look at architecture of Wi-Fi LAN. Okay, architecture is like this. Say we are talking about autonomous AP. Autonomous AP means every APs work autonomously. That means independently. They are not dependent on other controller or other AP. Okay. Say look at this network. We have a wide network. Wide network is core, distribution layer switch. Then we have access switch. Access switch are connected to APs. Okay, you say your university has different autonomous systems, autonomous AP. Wi-Fi APs are installed at different places. Okay, they are connected to access switch at different locations, but they are independent. They are not dependent on each other. That is why we called autonomous APs. And here, from VLAN point of view and networking point of view, look at this picture. You will be very clear. There are three VLANs. One is 10 for management, 100 for one SSID, and 200 VLAN for another SSID. Okay. So, so imagine all the APs have three VLANs connected. They are connected in trunk mode. So look, between your access switch and your AP, it is trunk mode, and trunk is passing 10, 100, and 20 VLANs. 10 is for management. In earlier session, we discussed that for management of routers, switch, and other networking devices, we can use separate VLAN, and which is dedicated for management traffic. Okay. And other two VLANs are for SSID. Okay, they are autonomous. So it is autonomous architecture. Then we have cloud-based controller. So another architecture is cloud-based. Okay, before that we go to this. If we want to configure Wi-Fi APs in roaming mode, that means you have different Wi-Fi APs in your campus, but users can move one APs to another APs, and still they are connected to their network without providing separate SSID or same SSID with different passwords. That is not required here. So people are conveniently moving from one serving area to another area. So it is accomplished using Wi-Fi wireless LAN controller, which is a central device that control all the APs, radio and different features are controlled from the central point, and your authentication is also controlled from WLC. That is, AP has only responsibility to transmit radio signal to your device and receive. Okay. And all the management functionality of the device and authentication are performed from wireless LAN controller. Okay. This is one architecture, and previous slide shows that it can be cloud-based controller. Your controller can be in the cloud. Okay, your cloud is connected to the network over internet. So all the control can be performed from cloud. Okay, in this figure, you can see that Cisco Meraki cloud is very well known cloud-based Wi-Fi of Cisco. So it is one type of architecture. That means we may have broadly three types of architecture. One is autonomous. That means all Wi-Fi routers are separate and work independently. And we have WLC based, which has the central controller. APs are in that case called lightweight APs. Okay, in this picture, APs are called, access points are called lightweight APL. Okay, lightweight AP. Why it is lightweight? Not actually indicating the weight of the device, not device. Okay, lightweight in the sense that it has less features or less things to do. Okay, in APs have DHCP server, they have netting capability or different functionality are there. But lightweight APs do not have these features. Okay, so let's discuss in detail about WLC based system. WLC based systems, APs are called lightweight, just I mentioned. WLC, it has controller, and lightweight AP has division of labor. Division of labor means they divided their activities between access point and WLC. Okay, this is also called a split MAC architecture, and a protocol is used in Cisco environment. It is control provisioning and wireless access points. It is called Capoff tunneling protocol. Okay, tunneling protocol encapsulates data between AP and now in access point and the central WLC controller is communicate tunnel, our GRE tunnel lab. Tunnel is the same concept. Okay, and tunnel data can be switched around. That means layer 2 and layer 3 communication is possible with this tunnel. Okay, Capoff has two types of messages: control message and data message. Control message is used for controlling or managing the devices, and data means the actual data transferred between users and different systems. Okay, and here is an important thing: authenticated and encrypted. That means data are authenticated and encrypted. So this tunnel ensures that your data is not available to anyone and who can intercept your data. Okay, so they are encrypted, authenticated. Also, your data packet is also encrypted by DTLS protocol, but it is optional. You can keep without encryption also. Okay. Do you have any questions with regard to WLC?
Yes, sir. For example, let's say consider about, let's say, a MikroTik router. Okay, we can create username and password to authenticate any user trying to connect to our wireless network. So can we achieve the same thing in Cisco, and how can we do that? Do we need to add another devices for that?
Of course, you have to install a dedicated WLC appliance. There is also virtual appliance are also available, which you can install in a server from where you can control. And you have a cloud-based appliance that is installed in cloud. And also another feature available in Cisco. In some Cisco suites, I can remember 6500 maybe the model of switch, which has a option to add a card in the slot of switch, which can be used as a wireless controller. Okay.
Yes.
But in a nutshell, WLC is a separate entity or appliance which can be physical appliance with application, or it can be virtualized appliance which can be installed on a server or virtual machine. And you have also a cloud-based appliance which is Meraki. Okay.
Yes.
And your APs, okay, APs are also different. in the sense that APs are lightweight APs. Lightweight APs have limited functionality because most of the functionality are carried out by WLC. But one thing you should know, in case of Cisco, as I worked with Cisco devices, interesting that Cisco APs can be switched between lightweight AP and autonomous AP. Okay, we can just change firmware. Okay, for example, we had some APs. Can you hear me? Sometimes my
Yes, sir.
network.
You can hear you.
Yeah, correct. In organization where I work, we had some APs. They are configured autonomous mode somehow. And when I joined there, I found that we have a WLC, but they are working autonomous mode without connecting to WLC. So what we did, we just changed the firmware of the APs and converted it to lightweight APs and connected to WLC. Okay, so it is possible in Cisco devices, but in so what you should remember, in WLC-based system, your APs will be lightweight mode, not autonomous mode. Autonomous APs has more functionalities than LAP. You should you use the knowledge of the CCNA up to now, like you studied NET. Okay, network address translation. Network translation is used in Cisco AP. Okay, our device received IP addresses from our Wi-Fi APs using DHCP server. Okay, but it is connected to ISP or router, which has different IP address. So these two IP addresses is translated in the router, in the AP. Okay, when it is autonomous AP, it just translates the IP address. Okay, NET is one thing, and DHCP server is also there in AP, but in lightweight AP, these features are not there. All these functionality goes to WLC. Okay, and look at this picture for more vivid picture. Look, Capoff, control and provisioning wireless access point is tunnel is created over your network. Okay, using AP and between lightweight AP and WLC. So what is the functions of lightweight AP? It is the function of radio frequency transmit and receive, MAC management and encryption. These are the functions. Okay, and the RF management. RF management means which every AP transmits signal using a Wi-Fi channel. Okay, there are fixed channels, a list of channels. You can find it from easily from searching, googling anyhow. Okay, so each 2.4G or it is 5G, which one you use? You have some channels. But what if you are transmitting your device with a channel, but with the same channel, someone near to your house is using the same channel, or some organizations Wi-Fi is also using the same channel. What will happen? There will be interference. If two devices transmit or receive signal are very near or within they are within a very short distance, the signal will interfere each other, and signal transmission, information transfer and receive will not be successful. Your data will fail. Your data transmission will fail. So what we do, we can manually change the channel, or device have some intelligence. So WLC has some intelligence. They can detect that this AP has a frequency, but they have a Rook AP which is transmitting with the same channel intentionally or unintentionally. Say someone is trying to disturb you or Wi-Fi network, or they can install a Rook device with the same channel and interfering or disturbing your network. It is possible. Okay, and this is Wi-Fi attack, Wi-Fi network attack. It is one kind of attack. So if you have a WLC can continuously monitoring with its intelligence that our AP is facing disturbance or interference from nearby AP. Okay, so in that case, it will switch to another channel. Okay, so it is not problem. Your handset, your handheld device or receiving device can, and also intelligently, dynamically switch to that channel without any problem. Okay, so look, it's a very important feature for radio transmission of AP. For good performance or good or better or user experience, WLC is good. Another feature then WLC can perform is that client authentication. So normally your Wi-Fi router or AP maintain the database pre-shared key or password that you use on your device. It is maintained by WLC. So you have 100 AP in your organization with a large area, or it is spanning multiple buildings. So if you want to maintain a pre-shared key on all the devices, it is not possible for you. So from a WLC wireless controller, it can be performed easily just from a single point. Okay, a single pane of glass, which is called. Okay, so you can manage from there. You can manage security of the system. You can check the traffic, whether it is for hacking or any other malicious activity are there. You can and monitor from there, and you can install DHCP server is there in the WLC. So you have single DHCP server. Otherwise, you would have to configure DHCP server on the APs, on autonomous APs separately. That is also disturbing. So you can configure, and network and transmission can be performed here also, or you can transfer the net option to firewall or your organization's router. That is also possible. And quality of service. There are different types of service. Say latency sensitive service like voice. Voice service is sensitive to latency, so it is called platinum type traffic. And then you have voice. You can call it gold. And then you have other silver, or you can say other best effort service. Okay. When we talk about quality of service, we will go in more detail. Okay. So what you have seen from here, that WLC can perform many central functionality and made the management easier for our Wi-Fi network administrator, and this is why WLC is required. Okay. What we already mentioned, AP has a different mode. APs can be in WLC-based system. APs can also have different functionality. Local means AP has transmit and receive and communicate with devices. Okay. And then monitor, and APs can be in monitoring mode. For some reason, you are configuring one AP as monitor to monitor different Wi-Fi network activities. Okay, it is for network analysis. You can use this. Okay. And you have Plex Connect. Plex Connect means if you have a WLC in your headquarter, okay, but there are your branch offices where you also use different AP controlled by central WLC, which is installed at your headquarters. Okay, what would happen if your headquarters and your branch office loses connectivity? For some reason, your fiber is cut or your Ethernet cable is cut, your branch office is isolated now, but still people are using Wi-Fi. What would happen? So Plex Connect mode, APs can communicate locally without connecting to WLC, especially in case when your WLC is disconnected for some reason. Okay, it is Plex mode. Then you have sniffer mode. Sniffer mode is when you collect network data secretly. Different devices transmit data and it is capturing. So it is sniffer mode. This mode is used by network analysts or hackers, also use to try to get some information from your devices silently. Okay. Their intention is to hack your network or your device. Okay. And then Rook Detector. Rook Detector means your AP can be Rook Detector. Rook Detector means there are some malicious devices installed by your enemy for some reason to disturb your network. So you can detect them from which direction they're coming. Okay, this is the reason. And then you have breeze mode, and we also discussed when we try to connect building or office just other side of the road. For some reason, we cannot install or lay cable. In that case, we are using a Wi-Fi AP to connect between two networks. Okay. Then we have okay. Most important thing, Wi-Fi security is important. Wi-Fi network has a special security threat. In your wide network, signals are communications signals, and your communication is going to Ethernet copper cable or fiber optic cable. So hackers can only eavesdrop or collect information, only have the access to those devices, switch router or cable some way. But Wi-Fi has challenged, although your Wi-Fi network is in your office or in your home, but signals are going outside your campus or your premises. So someone near to your building can intercept those signals and try to connect, and they try to hack your system if possible, or sometimes someone can maliciously use your network without paying money. Okay. So this is a challenge, but how we can protect our network through authentication? If you have a strong authentication mechanism, then no one can access to your network. Then you need to privacy. If you are using a Wi-Fi network at coffee house, which is free, or somewhere you are provided with free Wi-Fi connectivity, but it is not, the traffic is not encrypted. In that case, someone can intercept, or there may be some snippers are installed in the network, and they are trying to gather information on what your device is transmitting to and from, and they can get information, maybe your private information. Okay, it's possible. So what you can do, you can use the VPN in that case. Okay, one way. Okay, then integrity, another issue. Integrity means you are transmitting some information to somebody, or somebody is transmitting information to you, but someone working as a man in the middle, someone and in the middle between you and other, or between sender and receiver, they will intercept the message and modify and replay to you. Okay, you will not be aware that this is happening. So Wi-Fi security address issues in 3 areas, and these 3 areas are interrelated in some way. So let's begin with authentication in more detail. Wi-Fi authentication is very important. In the first place, you have to ensure strong authentication, otherwise everybody can log in. So open authentication is one option. So no credentials is required. No credentials are required in open authentication. Okay, you just connect the device. It is possible, but it is not recommended, because everybody will use it, and so there is no security. And there are personal or pre-shared key security method, where you have a string which you have to enter in your Wi-Fi as a password, for example. Although it is not password, it is pre-shared key. It is used for encryption. So there are different authentication protocols or a standard. It has also gone through an evolution, and still it is evolving. In the past, we had WEP, wide equivalence privacy. I again show you. Okay. Okay, you can see, look, there is WP2 and WPA. Two options are available. Okay, but in some routers, you will have WP, WPA, WPA2. Three options. WP3 is a recent development. It was released in 2018. Not all Wi-Fi routers, Wi-Fi controllers support this mechanism. Okay, WP3 is not implemented by all. Okay. 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 So at the beginning, okay, there are another option, enterprise option, that is called .1x EAP, which I also discussed in the previous session. Okay, extensible authentication protocol. Okay, in the past, okay, at the beginning, the authentication method was known as wide equivalent privacy, WEP, and then sorry, it also used pre-shared key. That means it required to use a key or a string that similar to that we use now. Okay, and the encryption protocol was RC4 algorithm, and it is no longer secure. So it is not secure, but you will see WPA in many WLC or Wi-Fi access point or Wi-Fi router these days also. So these are kept for two reasons. One is these devices are old. Another reason is for backward compatibility. Backward compatibility means you are installing a controller, but in your organization you have some old devices, and in case you want to connect to the device without backward compatibility, you will not be able to connect, because advanced protocols may not be available to those devices. That is why sometimes newer devices keep old protocols, old standards to optionally use with those devices. Okay, and then came WPA. Why WP is not used nowadays? Because for hackers, it requires only 60 seconds to hack WP standard. Okay, only 60 seconds or less than 60 seconds. Okay, they will get your password. Okay, and then came WPA, but WPA is also weak. It is also hackable easily. So WPA is also abandoned. Okay, but it's still available for backward compatibility. So be careful when you use Wi-Fi or configure your Wi-Fi. WP and WPA should not use. Okay. Yesterday I was visiting to a client's office. Somehow I requested them to provide Wi-Fi, and they provided. When I connect, I found that they are using WPA personal mode. That is not secure. I received a security warning on my laptop. Okay, letter I disconnected. How about this? Okay. Okay, you may get this type of configuration in some organizations which is very old device, which are using old devices, or they are not um, security aware, okay, or security conscious. And then came WPA2, which is secure. Okay, we prefer WPA2, which use AES, Advanced Encryption Standard with Counter CDC MAC Protocol, CCMP. Okay, just remember AES CCMP. It is very strong and acceptable encryption algorithm these days. And in 2018, WP3 is also released, but it is not widely adopted. You will not see in devices. I don't know whether most latest the device have this WP3. Okay. And let's compare all these all the protocols. WEP is not mentioned here because we will not use this, and you will rarely face WP. Okay. Then what are the differences? WP and WP2 and WP3. WP is also old, and we will not use it because it is also vulnerable. Hackers can easily hack. WP2 is only, and WP3. And pre-shared key. Okay, all three protocols support pre-shared key. Pre-shared key is very known to you. We just enter a string or password. It's called, okay. And then the 802.1x EAP. It is called Extensible Access Protocol, EAP. Yes, EAP is supported by all the three protocols. Then MIC. MIC means message integrity check. Message integrity encryption and message integrity check is Eap. Temporal key okay, Eap, what is the full form of Eap? Temporal key integrity protocol. Okay, temporal key integrity protocol supported by, okay, Eap is old. Okay, when someone within a 60 seconds, within 60 seconds, so they develop protocol and created Eap protocol for which is used with the protocol. But later it was found that Eap is also vulnerable. It is not reliable. It is also hackable all by any malicious actors. No problem. But it is not used by WP2 and WP3. So we will not talk about Eap. And encryption method MIC with AES and CCMP and ZCMP, two protocols. CCMP is used with WPA and WP2, but ZCMP is used with WP3. So in a nutshell, you can see these features. Okay, let's talk about some integrity. Okay. The heading is wrong. It would be integrity. Okay. Integrity. Okay. Integrity means your information is unchanged. What you are sending, receiver is receiving the same, and what your sender is sending to you, you receive the same. This is the main idea of integrity. Okay. Do you have any question or anything? Or
No, sir.
add anything?
But how can we ensure the integrity?
Okay. Integrity, basic concept. Integrity. Okay. Good question. Authentication, you understand that you are protecting using your password kind of thing. Okay. But
Yes.
how I am sending a message to you. Okay. And you are sending a message to me and written that it is authentic. You are sending a message, but someone in between intercepting the information and changing all the message and sending and to me, and in the end it is authentic, no problem. Okay. It is possible. It is integrity violation. Okay, I think that is okay. I am getting this message. Okay, yeah, correct. But it is intercepted by someone and changed and sent to me. So mathematics, yeah, okay. If you are studying computing, it would be easier for you to understand. In computing, we know 2 or 3 concepts regarding integrity. One is cyclic redundancy check, CRC, or hash, another hashing algorithm. 2 interesting concepts. So if you are sending a message, okay, correct. And with the message, you are also calculating say cyclic redundancy check. Or we can talk about hash. Hash means with algorithm you are calculating a value. Okay, at first CRC. I am not going. CRC is a very long mathematical concept, but what is the base?
Yes, sir, we have learned it in our
CRC, right?
Yes.
From the message you calculate, you get some value. Okay, you get some
Yes.
value, which is unique to that message. If you send that message to me, say for example other channel, and then you are sending the message to me. Okay, now I will also calculate the CRC using that message and compare to 2 CRC. If 2 CRC are the same, then I am sure it is not tempered in between. No one and change it in between. So I am sure. So in this case, we are not talking about CRC used for point-to-point communication or data transfer. But when we talk about information as a whole, hashing is used. Hashing has one important feature, that using one algorithm on a message, only one hash is possible. However, if 2 hash is somehow possible, that is not good algorithm. That is called collision. Okay, this is called collision. So with advanced hashing algorithm, if we hash anything, we will get unique value which cannot be reversible. If I give you hash, no one can say that from which message it is obtained. Okay, so it is interesting feature of hash. So if you send a hash of the message with the message to me, In that case, it is possible that no one changed the hash. But you can say that in between, someone intercepted the message and changed the hash also. It is possible. So in that case, encryption is there. You will send hash and message in encrypted form. So in that case, at first I will decrypt the message and then create a hash from your message and check that my calculated hash matches with the hash you set. If that is the case, in that case, I got rightness. Okay. Otherwise, it is tempered or manipulated by someone else, or sometimes it is possible that communication channel may be disturbing. Some data corruption is possible. So in that way, it is also possible to corrupt the data. Okay, that is unintentional, but intentionally, man in the middle, someone in the middle can manipulate integrity. So it is very important concept. So if you understand encryption and integrity by hash, then I would say you are in a good position, because these concepts are actually critical and difficult also, and sometimes they are not clear to all. So another way to make, okay.
Let's say that the attacker is not changing the information, but rather maybe he's listening to the communication. For example, let's say that I'm talking with someone. So the attacker is not going to change the information, but he will listen what we are talking. For example, using, let's say, YP protocol analyzer like Wireshark or any other hacking software. So in that case, is there any way that we can ensure that no one is listening to our communication?
Yeah, okay. In that case, you use encryption. When you encryption without your encryption key, no one can decrypt your data. With packet analyzer, Wireshark or similar type of analyzer, it is not possible to decrypt encrypted traffic. Okay, encrypted traffic can only be analyzed by brute force. Brute force means you use all the possible combination of key, but for that you may need say 500. Say 500 with our computing capability, you may need 500 billion years. Imagine. Okay, so it is impossible to obtain. So in that case, it is not possible. Okay. So, however, if you are using very old encryption protocol and your encryption key is very guessable, say 1, 2, 3, your password. So someone will guess, okay, let's try it 1, 2, 3, 4. Okay, he or she gets your message. Okay, you are using a strong encryption algorithm, but still you are using very weak key or password. So it is adding no value. It is pointless. So this is another problem. Anyway, we are talking about wireless integrity, and another techniques are timestamp. Okay, your message has timestamp. So you are sending a message with now for 11:40 a.m. Some seconds. Okay, and you are sending this, but someone is taking this message and take some time to manipulate, and then so receiver will not receive because it has timestamp is stale or it is not up to date. Okay, this is another. And long initialization vector is to prevent brute force. Initialization vector means you will take some arbitrary string of some bits. Say your key is some say 128 bit wrong. Okay, and now your initialization vector is arbitrary value, something whatever a value. Then you will add or JOR. You know JOR operation in computing and binary operations, and or not JOR. Okay, XOR. So you XOR computed with this, and then your key is different with initialization vector. So it will give more randomness to your key, which will prevent brute force. Okay. Actually, brute force is not preventable in general sense, but brute force takes a huge time if you have strong encryption key algorithm. It may take billions of years. Okay, but who knows, with latest development in computing, like your cloud, what about quantum computing, say, who knows, they will get huge computing power. Okay, unimaginable maybe. Okay, however.
So the longer the password, the longer it takes the attacker to break.
Yeah,
to break it.
Yeah, you are right. The longer key is better, but make sure that it is a combination of uppercase, lowercase, a special character, and numerals are all included. Okay, in that case, brute force will take a long time. If you use only numerals, 0 to 1, 0 to 9, or use only uppercase or lowercase, it will take not that much time. Okay, and that in the organization, only using password is not sufficient. Okay, you use only key string. So look, you are using your Wi-Fi. You are given a key string that all of the students are using. Okay, or a key string is given to administrative staff, and they all are using the same string. So you have no way to identify who is using the Wi-Fi network and who is doing what. Okay, in that case, you are using 802.1x Eap authentication that I used in a lab in the last session. Okay, so Eap, you have to install a radius server, a TechX plus server. In addition to WLC controller, with WLC, you delegate your authentication activity with radius or TechX server. Okay, anyone, not both at the same time, however. So radius server will keep a database of users who are connecting to your Wi-Fi network. Okay, you will create individual username password for every user. So in this case, you keep track of Wi-Fi activities, who is doing what and when and why. Okay, so it is very important. So there are also this concept, how Eap authentication works. Say your device is supplicant. Supplicant means in plain English meaning is supplicant who prays to get something. Okay, supplicant prays to get authentication. Okay, to whom? Each authenticator. Okay, here WLC. And WLC has no database of the user. Who has users authentication? Users authentication data has authentication server. Authentication. What is authentication server? Authentication server is Radius server or TechX server. Okay, Radius or TechX has their database of users. Okay, WLC just collects those use that information and provide to the supplicant. Supplicant means your device. Okay, which wants to connect to Wi-Fi network. So this is called EAP, Extensible Authentication Protocol. Although it is protocol said, but it is not protocol, it is a framework. So there are different techniques of EAP you can study, but basically there are different techniques, lightweight EAP, Eap Tls, Eap, protected EAP are notable, but LEAP is not secure now, so it is deprecated. Deprecated means it is no longer in use, it is abandoned. Okay, Eap Tls is a very good protocol because you not only verify verify or authenticate server, but also the device. So your device needs TLS certificate. In HTTPS, you know that servers, web servers have a TLS certificate, and the clients only verify that it is right server. So one-way verification. But what if client is actually malicious? So in that case, client needs to install TLS or SSL certificate, but that is difficult to enforce. But Eap TLS is similar protocol. Client side and both server side needs certificate. But how can you install TLS certificate on all the users? Say you have 2,000 users. It is difficult or costly. So it is not widely used. PF is widely used, so it needs only server side certificate. Client side, for client side, you use just password based authentication from server side. Sorry, client side. Client side means your device. Your device need to enter a password or key string, but server has some TLS. Okay. There are other EAP authentication methods, such as EAP SIM card can be used as authentication, and other protocols. Okay, you can go to on your own. And then we have WLAN. How we can deploy and configure enterprise WLAN? Okay, you are a imagine you are a network engineer or network administrator responsible for deploying Wi-Fi network for your organization, or you want to upgrade your network. So previously you may have a network that is autonomous system or Wi-Fi router based. Now you want to deploy a WLC based. How you start your work? So before deployment, you collect requirements for an license. Okay, you will collect business requirements. So your management will say that we need Wi-Fi in this areas, and we need roaming. So you will collect the information and also collect who will you get the Wi-Fi access. Okay, in some organizations, some support workers may not get Wi-Fi. Okay, it's their business decision. You will collect. So you will exclude them. If your organization say that no, everybody will get Wi-Fi, okay, you will take into account, and then you will go for surveying. Okay, you will survey. Why you will survey? Survey is required to get information about different areas of your Wi-Fi deployment scenario. Okay, let's say one room is very small, so you will install a different type of Wi-Fi AP kind of. Okay, or you will see whether there is switch for connectivity. Okay, Wi-Fi APs need connection. Okay, connection to your access switch. So you have to check whether your switch is available. So you write down in your notebook whether you can connect or how you can connect. And power, for power you have no problem because AP support power over Ethernet. So you don't need to get Wi-Fi, power outlet or power socket anywhere, because power is transmitted over your Ethernet copper cable. Okay, so you are getting all the information from different sources, then collect all the information, and then you will architect your design, how you will install in which points in the ceiling, where you will drill your device to connect, or how you can fit with the false ceiling. Okay, or it is called suspended ceiling. Okay, or wall. Maybe it is wall mounted. Okay, so you have to plan everything as a part of survey. Then you will architect your design your network, where your WLC will be. WLC has different capability, how many users you have, and then you design a network, you develop a network diagram in your, say, Microsoft VCO, and then you will develop IP address planning, how many IP address will be used, your subnet mask, and you will use your SSID name, how many SSID will be used. Okay, everything, and then you will document all these things. Now your plan is ready. Okay, then you will involve others along with you for installation of hardware. Say you may have some installation team, or your contractor will install all the devices according to the plan, and then WLC configuration, and then you will configure WLC. And WLC is basically a web-based configuration. And in the configuration, you will configure DHCP, NAT, radius of attacks, quality of service, wireless SSID, authentication, security protocol. There are several different configuration you will configure. And then you will configure the switches, where it will be connected. Okay. How the VLANs, you will use different VLANs for different SSID. Everything will be documented and implemented accordingly. So, and after that, you will test your network whether it is performing as per expectation, or you will collect user experience from different users by interviewing, or you will again survey, conduct survey to get the information whether your network is performing as per plan or as per expectation. And once it is installed, then it is okay, your network is operational. Okay. Okay, is it clear to you how we implement a network in enterprise environment? Okay. Do you have any question regarding this?
No, sir. It's okay.
Okay. If you understand, that's great. Okay. Discussion is here. That's all I would say. If I say this is CCNP's CCNP that syllabus, I would say. That's all I would say. But you can study further. At least if you understand all the concepts here, you will have the confidence to work in environment, professional environment. Okay, and while working, you can study further or learn many things, and you will get better knowledge. Okay. So what's about our? I have got one. Sorry, I have got one lab only, but it is very simple lab, I would say. My board is somehow safe mode. Okay, in packet tracer, are there are wireless, okay, wireless devices, many wireless devices, but they are not properly working. I have gone through yesterday. I checked that what are the devices? There are different devices. Okay. At first, let's discuss what are the devices available here. Okay, I told that system Meraki. Okay, it is Meraki. Okay. Meraki device. Okay, we'll not discuss. And then lightweight. I told the lightweight access point. Okay. Lightweight access point. Okay. Yeah, here you can see that. What are the configuration? Oh, we have to power on. How to power on? Okay, maybe it is on. Power on. What is this? Okay, power on, I think. What is that? No, no, it is off mode. Okay, somehow it's working. Okay, not working somehow. Let's go another way. Then WLC. There is a WLC. Okay. Cisco has different WLC. For example, C5 work model, C5 00 series. Okay, maybe this one. Okay, but here all the features are not available. Okay, that is very poor virtual device. Okay, very poor virtual device. There is very little configuration. Okay, there are also other devices. Say this is wireless access point that is similar to our home router. Okay. Okay, let's connect. Okay, let's say we take a tablet. Let's take a tablet, say Wi-Fi capability. Okay, so if we have maybe okay, look, it is receiving look, Wi-Fi signal is receiving, that is this showing. Okay, say it is Wi-Fi router, but is it power on? Okay, it is Wi-Fi. That look, how we configure our Wi-Fi router at home. DHCP There may be DHCP static or PPPO point-to-point protocol over Ethernet is used by various small ISPs, home router, home users. Okay. Look, PPO can be used static. Static means specific IP address is connected to one your ISP to ISP internet. This configuration we use for ISP connectivity. Okay, ISP will give you some IP address, subnet mask gateway. Okay, DNS server also provided. Okay, and you will put and your router is connected to internet. Very easy. Or you can use DHCP. IP will be dynamically received from ISP's DHCP server. Okay, it is also possible. And then also PPOE, they just provide username, password, and it is a layer 2 connectivity somehow. And then IP address and mask default gateway and DNS is also get from DHCP server of ISP. Okay, but another server is involved in PPOE. Okay, but in larger organization you will not see PPOE. In that case, you will say a static connection. Okay, and then you have LAN and then you have wireless. LAN means when you purchase or if you see your home router, you will see that there are some LAN connection ports. Okay, you have also Wi-Fi. For Wi-Fi, you can see you can you can have different authentication method. Okay, can you see this? Okay, is very practical point of view. Okay, here authentication that is often authentication, right? And then you have a WPA, WPA2, and WPA3 is not available because it is not available till now. Okay, and WP. And if you select WP, then we can select key. What is the password? Something. Okay. Okay. We can set. Then we can use WPA2. Can also passphrase WPA2 with WPA2. Two options there are. One is personal and pre-shared key option. Another is radius server. Okay, Eap. Okay, two options are available. So in this way we can get this. Okay. For LAN, you can see that there is DHCP IP range somehow. Okay, let's see whether this tablet can receive any IP address. Okay, it receives IP address. Okay, so it has built-in DHCP server and it is working. And look, this device has received so DNS. Okay, received the IP address from this range. Okay, 192.168.0. Okay, but DHCP configuration is not shown here. Okay. Okay, let's move on to the lab. Okay, lab you should do yourself because it is very simple. You will take a router. Okay, router has interface, and this interface is IP address 168.1.1. Okay, then you have a Eap. How we can construct? I just construct and configuration will be done by you. Okay, we just showing this network. Okay, delete, then delete. Okay, let's take a router. Take any router, no problem. You can take any router, and then take a PC. You have a PC. No, I should take. No, I should PC. Let's take tablet. Okay, PC is also possible, but Wi-Fi needs to be enabled. Okay, and then we have this APTT. Okay, let's take it. Okay, now connect. Okay, Wi-Fi get. Wi-Fi has. Can you see this? Okay, and now look in this. You have IP configuration DHCP. Okay, now 169 series IP is got, it is AIPA automatic configuration. It is not the real IP, but it is link local actually. But DHCP IP is not possible here. Okay, there is no DHCP server. So what you will do? You will static and configure the IP address as per my as per lab manual I am providing. Okay, then you will configure the router port, and you will configure using this AP. This AP has limited capability. Look, you port just Ethernet. You have nothing to do here. Keep it as it is. Okay. But you can set password or passkey here, okay, and that can be used with this. Okay, it is very simple, and just test your reachability to the router's router's port as per manual. It's very simple. So I am not doing sharing this lab. But in this packet tracer, I am seeing that WLC are there, but I could not find any features that can control APs, lightweight APs. That is why I am not giving any lab. Okay, but there are many options. Okay, but you can see these controllers. Okay, the controller, in controller you can see many features. Okay, the display name, then Wi-Fi. There are different protocols. Okay, are there. Okay, radius server or TechX can be added here. It is possible. Okay, and SSID name can be given, and VLAN can be set, and then AP groups name can be set, but it is not possible to change, or maybe there are some problems. Okay, then you can set your DHCP server. Okay, for DHCP server you can set your IP address, etc. And you have management IP for device management. You can also set IP. So you can just go through this, but in real WLAN controller is in more detail, but you can read books which will give you more detail of snapshot at least, and you will see that there are different options that you can configure. Okay. Do you have any questions? Or we can finish today's session. Or do you have any thing to say? Okay. Okay, I am providing you the lab and also the slides that that you can go through before in-depth study. Okay, do you have any question? Okay, what about what is the list? Okay, take the list. Okay. I'm taking a snapshot of your attendance. What is, okay, here is one. That snapshot is the card. That is the last section. Okay. Okay. Disturbing over. Okay. Taking the snapshots. Okay. 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 Let's finish here. Thank you all.